Under the Mobil Serv offer, this video is a piece of the hydraulic system inspection on-the-job training curriculum that will enable you to convert customer needs and opportunities around hydraulic systems into improvements in safety, environmental impacts, and productivity. The video is the first part of the OJT for hydraulic system inspection. After viewing it, you should job shadow another competent person completing a hydraulic system inspection, and then have the competent person observe and coach you as you complete an inspection. The OJT Participants Guide provides an effective way to guide the trainer and trainee through the experiences to gain knowledge and capability. Eric, a field engineer with Mobil, has been working with this plant on a number of Mobil planned engineering service projects. Jeff, his contact at the plant, tells Eric that he'd like them to focus on some hydraulic system problems.
Having some troubles on my 10-8 machine winder hydraulics tank. Getting some water in my oil. I'm not sure where it's coming from, but it is causing some downtime for us. I'm plugging filters, and it's causing some problems in our servo valves as well.
Eric works with Jeff to understand the impacts of these problems, so he can later use this information to show how his findings and recommendations can reduce these impacts and produce value for the customer. Eric and Jeff had been mutually planning a hydraulic system inspection. Now, this was their opportunity. For some customers, Eric performs routine hydraulic inspections to proactively look for improvement opportunities or detect abnormal operating conditions. To help bring solutions and value to his customer, Eric must be an excellent detective and must collect the data needed to help determine the root cause of the hydraulic oil problem. Before meeting Jeff again for the inspection, Eric gathered information about the hydraulic oil makeup and change frequency, also the hydraulic fluid index. You determine this index by dividing the estimated annual oil consumption by the reservoir size. Systems with the highest HFI may prove to be the ones with good potential for investigation. Achieving an HFI under 1 is a good goal. He also learned how hydraulic oil is stored and handled at the plant, and how it is added to the hydraulic system reservoirs. Eric also went over his safety preparations, like customer site-specific training. Many locations have, at minimum, a visitor orientation video. He also read through the Job Safety Analysis, or JSA, to review the risks and determine the best mitigation steps, including PPE. Then, Eric prepared and reviewed his toolkit for the site visit: hydraulic system inspection worksheet, flashlight, digital camera, infrared gun, thermographic camera, oil sample kit, rags, and hydraulic system schematics or piping diagrams. On the morning of the site visit, Eric and Jeff first review their goals for the visit. Eric goes over his safety plan, and together they review the personal protective equipment they'll need: hard hat, safety glasses and hearing protection, cut-resistant gloves, visibility vest, and anti-slip steel-toe boots.
I think that should do it.
Let's go to it.
Let's get her done.
One of the first items on Eric's SOP, the standard operating procedure, is to inspect the entire hydraulic system, as safety procedures allow, including the reservoir, lines, hoses, valves, filters, heat exchangers, motors, and actuators. He also wants to visually check for leakage at fittings, lines, and hoses. He checks the different components for dirt ingression and for abnormal vibration, noises, and temperatures. In this case, as he is walking the entire hydraulic system, he notices this leak from a pipe above. It's hydraulic fluid coming from a loose fitting. Jeff calls for maintenance staff to tighten the fitting and clean up. At the reservoir, Eric checks pressure gauges on the main oil filters, pump inlet filter, and kidney loop filter systems. He knows that too high a pressure difference between a filter housing upstream and downstream can indicate that filters need to be changed. Eric uses his IR gun to check temperatures at the reservoir, pump, and valves. He wants to check the delta of temperatures at the heat exchangers. Optimal temperatures for critical parts of the hydraulic system are listed in the SOP. Eric listens for abnormal conditions like these: surge, cavitation, cavitation with back pressure, and aeration. Then Eric begins the process of taking an oil sample. In this case, the only good way to obtain a representative sample is by using a suction sample gun. For best future results, Eric may recommend that the customer install sample ports on the pump discharge lines before and after the filter. He cleans the area around the sample point location. He uses this opportunity to look under the oil fill cap and inside the top of the reservoir for signs of rust from moisture buildup, which can be from poor reservoir ventilation, especially in humid conditions. He uses clean sample bottles and a clean sample thief and hose. To take a representative sample from the reservoir, targeting the middle level of an active part of the reservoir, Eric first purges into a sample bottle. Then, putting a new sample bottle in the pump, he purges 2 samples before drawing the representative sample. When done, Eric visually inspects the sample for water, sediment, and color. He then cleans any spilled lubricant or debris and secures the sample point. Jeff will submit this and other samples for analysis. After his site visit and hydraulic system inspection, Eric will go over his findings, including measurements and photos, to prepare an engineering service report for Jeff and his supervisors. He must take in all the facts and sequence of events to determine the potential root causes. He must work with his customer in cooperation, not only to gather the information, but to form the recommendations that will produce the best value. Some recommendations could include improve contamination control, for example, by enhancing oil filters and reservoir breathers, and by improving top-off procedures. Incorporate new, routine operator inspections to prevent heat exchanger plugging. Reduce oil leakage, for example, by sheathing lines to protect them, and upgrade to a hydraulic oil better suited to harsh conditions. Eric can demonstrate that his findings and recommendations produce an excellent return on investment and value to his customer. To do this, Eric should also identify the as-is costs in terms of valve, pump, actuator, and oil replacements. Eric and his sales advisor will use this report to promote our value to other key contacts at this customer. If very well received, this engineering service report could become the foundation of a proof of performance from this customer that could be used to show other customers to convince them that ExxonMobil and its distributors are the right lubricant supplier for them. In addition to helping this customer in this one application, Eric will look to see how he can help the customer apply what they have learned to other similar machines at this facility or across their entire company. By using the standard operating procedure as a guide, as well as the other tools described, Eric can consistently conduct these inspections and deliver outstanding value to his customer.